Hi Pi. So today we're going to talk about taking our sine waves and cosine waves and not only using amplitude and period to draw the picture, but now we're going to take those and move them around from the x-axis, from the origin, moving them up and down, left and right. That's called shifting horizontally and vertically. Let's get started. I hope you have your notes sheet available and you're ready to write some things down. Hi, so this first part is going to be a bit of review. Here we're talking about y equals sine of x, y equals cosine x. Those are known as our parent functions. We've been talking about those for a while. So everything we talk about, and when I draw graphs, you're going to see me refer to the parent function quite a bit. In my examples that I'm showing you today, I'm using y equals the sine of x. You can see that there's one full cycle of sine of x, has a high and a low of 1 and -1, just like we'd expect. The period is 2 pi. Nothing too earth-shattering. In this next set of problems, what I've done is I've taken my sine and function and I've multiplied it by some number. I'm sharing with you what happens with the sine function. The exact same thing happens with the cosine function. So I have my sine function multiplied by a 3. Last week we talked about how that number is known as amplitude. And amplitude tells you the highs and the lows of your function. We should note that that high and low right now is measured above and below the x-axis, so that we've gone 3 spaces above the x-axis, 3 spaces below, and so on. We did not have any effect at all on the period of that function. It's still the same as its parent, 2 pi. This next picture that I have is what happens, how do we change the period? So in these, we had y equals the sine of some number times x. Could also be the same if I had cosine. That number b affects the period. If I do 2 pi divided by the period, I have the number b. Or if I want to know what the period is, I do 2 pi divided by b. So what you see here is in red, I have my original sine function, and it had a period of 2 pi. Now when I do sine of 3x, I've got 1, 2, 3 cycles in that same period of 0 to 2 pi, so that the period of this function is actually 2 pi over 3. That's the period of my new function. This is all review stuff we've talked about before. Now what we're going to do is we're going to look at doing some different things to our equation. In this next picture, I've got the red graph is the y equals the sine of x. The blue graph is what happens when I do sine of x plus or minus some number. This case, my number is pi over 3, and that picture is the blue graph. So in terms of a generic equation, this would look something like sine of x minus some number that I'm calling c, because I've already used a and b. Could also be the same if I'm subtracting c within the cosine of x function. That number c represents a left-right shift. You'll notice that when I look at that picture, my high point has shifted, my low point has shifted, where I cross the x-axis has shifted. Everything has shifted to the right. We subtracted pi over 3. We moved to the right. Everything here moved to the right pi over 3 spaces. So in our equation, if we have x minus c, that's going to take things and move things to the right. If I have x plus c, I'm going to move things to the left. Now, another little detail, another little nuance in here that I haven't included is what happens if I combine my problem and I actually have a number in front of x as well as this minus 3. If I happen to have a b here, a number here instead of just a c. Well, if that's the case, if your equation has both a number for b and a number for c, the distance of that shift is actually c over b. We have to take that b into account a little bit. We'll do an example with that in just a couple of minutes and show you what that would look like. This next thing is what happens if this thing that I was adding or subtracting is not part of the sign of x, if it's outside of the parentheses that go with the sign value. In this case, we're looking at something like sine of x plus, now I'm up to d. I've used a, b, c, now I'm up to d. The same thing will be true if I use the cosine. And that d, what did it do to my picture? The red is still my parent function. This plus 3 took my graph, took every point, here's my high point, took that high point, moved it up 3 spaces. Took this x-intercept, moved it up 3 spaces. So d takes my graph and moves it up or down. If it's a plus d, we're going to go up. If it's a minus d, we're going to go down. The easiest way to do that is to take your 5 key points and take those key points and make the movement. Take them all, move them 3 spaces up, and then redraw your equation. If I moved them all 3 spaces up, I would be here, and I can easily connect the dots and draw my function. So if I'm going to put this all together on one page, and this is exactly what I have for you on the back page of your notes. If you have all of these things together, A's, B's, C's, and D's in an equation, here's what happens. We know that A is the amplitude, that's the high-low. We've got that figured out. You guys are really good at that. Here's the B. The B is 2 pi over the period. So if you're given an equation and you're asked to find the period, you're going to do 2 pi over B. This C is something new for us. This C is a phase shift. We have to remember that if in the equation, if we have some number x minus C, that means that we're going to go to the right. If we have that some number x plus C, maybe those should be in parentheses, we're going to move to the left. And quite often you may get lucky and not even have a number B, so it's just the phase shift is whatever that number C happens to be. This will be a tricky one. We'll do an example with that in just a second. The last one is this D. D is a vertical shift. If the equation says plus D, we know we're going to go up. Vertical means up and down. If we're going to do minus D, then we're going to go, down. So let's put it all together into one equation. This equation has A is 3, B is 2, C is pi, don't you love it, D is 1. First thing I'm going to notice is that the amplitude of this cosine function is 3. The period of this cosine function is going to be 2 pi over 2. So if I come over here, 2 pi over 2 is what in lowest terms? That's pi. Go to the very end of your x-axis, label that pi. Go halfway, that's 4 spaces out. That's going to be what? Pi over 2 then we've got half of that is pi over 4, so 1/4, 2/4. This next one will be 3/4 of pi. So if I take this and I try to graph just this part with an amplitude of 3, that brings me up to here. At this point at pi over 4, I touch the x-axis. At pi over 2, we hit a low of -3. At 3 pi over 4, we hit the axis. At pi, we're up here. So what I really have is something that goes just like that. Isn't that beautiful? Cosine function. Now what I've got to take into account is I've got to take into account the shift. The shift is c over b, so I'm going to write pi over 2. And because it says plus here, that tells me that I'm going to move to the left. This +1 tells me that we are going to take that graph and move it up 1 space. So if I take this graph as I see it here, and I take each of the key points and move them pi over 2 to the left. How many spaces is that? Well, from here to here is pi over 2. So on my graph, that's 1, 2, 3, 4 spaces. Take each key point and go 1, 2, 3, 4 spaces to the left. 1, 2, 3, 4 spaces to the left. 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces. Now I've got to take each of those and move them up 1. So here's my first big point. I should probably do that in a different color so it stands out better. Here's my first big point. Move this one up 1. Take this one up 1. Take this next green one, move it up 1. And this last one, move it up 1. I have a lovely picture of my cosine graph, and I can continue that. I can extend that as I need to, and I've got just a great picture of what's happening here. If I even continue going, where we're headed with all this is we're going to take all these and figure out what kind of real life problems can be solved with these kind of functions. So it's kind of important for us to know about how to extend them. Here we are, we're here. Isn't that beautiful? Well, what did you think of that? Do you think you can handle that? Tomorrow in class, we are going to take a look at 5 equations. So tomorrow in class, we're going to go ahead and finish this up. We're going to talk a little bit about giving you some examples. I'm going to give you some trig graph paper and we'll graph 5 examples. Before we say goodbye, if you would please on your note sheet write down any questions, comments, anything that you might have a question about what I've presented here in this video so that we can address those in class tomorrow. If you think of it tomorrow, colored pencils. I'll have some in class, but if you have colored pencils, we'll use those tomorrow in order to tell our graphs apart. Have a great day. Bye.